Presentation is about ShadowRay. It's about a vulnerability that was discovered inside of AI and one of the first targeted exploit that was discovered in the wild. So that's the topic of this conversation. You're not going to hurt my feelings if you want to leave right now, but I'll lower the expectations. Perfect. I'm good with that. I can definitely do good with low expectations. So I'm going to spend the next 30, 45 minutes or so talking about a vulnerability that our research team discovered and some of the details behind it. It's very interesting as far as the process that we use to actually discover it, and what we'll do is talk about a few topics as we go through here. So I'm going to start with a quick introduction of myself. So I'm McCully. I'm with Oligo Security. I don't know if some of you sat in on that last presentation with Roger. From Ballistic. We're actually a Ballistic company too, so it was awesome to hear him talk. I'm a field CTO at Oligo Security. I've been in the security space for a long time, close to 2 decades now, 3 decades in security, with a little bit of everything: SaaS, DAS, mobile, networking, dabbled a little bit of stuff. I'm excited about the technology we have at Oligo, but I'm going to spend most of the time talking about the actual discovery that we found. On a personal note, because I always think it's interesting to at least share a little bit personal information. I grew up and spent most of my time 2 states north of here, so up in Kansas. Moved to outside Chicago for about 20-some years, and then just 3 years ago or so, I decided that I got tired of the cold weather, decided to move to Florida, which I thought at the time was the best move ever. And then I realized I had a very, very unique skill set. And if any of you guys have figured out a way after this talk to tell me how I can monetize that skill set, it would be amazing. But I have the skill set of being able to identify and purchase a home that historically has not been targeted for hurricanes, but within the last 26 months have had 5 hit it. So it's been very, very fun. So yeah, the last 2, Helene and Milton, we took direct hits. So it's been fun. If anybody wants to discuss hurricanes and sort of the ideas behind them, I'm becoming an expert. Jim Cantori shows up way too many times in my neighborhood. So with that said, we'll actually focus on the presentation itself. So I want to start out with talking about shadow vulnerabilities. Any of you heard of that term, shadow vulnerabilities, by chance? Amazing, love it. Perfect, then I'll fix that. Part of my goal is to do a couple things. 1, promote awareness of what shadow vulnerabilities are. And then 2, to talk about a shadow vulnerability in AI that led to us discovering this attack that was being actively exploited in the wild, the first known attack. Most likely not the last attack that we'll see, but definitely one of the first ones that we saw actually exploitation of the wild. I'm going to talk about open source and AI infrastructure and the idea of shadow vulnerabilities inside of them. Then we'll spend the last part of the time talking specifically around the vulnerability our research team discovered that we labeled ShadowRay. And it's with the Ray AI engine. We'll spend a little time about that if you're not familiar with it. Last, we'll wrap up with just a quick sort of, what do you do if these vulnerabilities exist and how to protect yourself, and then questions if we have time at the very end. Cool. So shadow vulnerabilities, what are they? Much like the term shadow IT and shadow applications, right? There are this idea that there's vulnerabilities that exist that you may not be aware of. With the old adage, if a tree falls in the forest, does anyone know about it or hear it? In this particular case, these are vulnerabilities, and there's usually only 1 or 2 people that actually know about it. Those are usually the maintainers. This is a pattern that we discovered across lots and lots of open source. And we'll talk about the details of what they are. These are vulnerabilities that may have been discovered and actually shared with the maintainers, but the CVE is very often disputed. And we'll talk about some of the details behind what that was. As part of this, as part of that disputed process, there was multiple sort of details shared as far as why it was disputed, meaning the vulnerability is there because that's the design of the open source project. Or the security controls are in there, it's your responsibility to use them appropriately. There's also capability silent configuration, which means the default settings sometimes expose you to these attacks, and you may not be aware of them. One other sort of interesting tidbit is a lot of these are actually mentioned in the docs themselves. Who is going to be the first one to admit that they read all documentation as far as for open? I'm not there either, right? And how could we expect developers to read all documentation on every single open source library that they ever use inside their code, as well as the versions and how they change? It's just not, it's not palatable. It's not something that's most likely possible. And if you don't read the documentation, then how are you going to be aware? So with that said, if you actually start looking at some of the most popular open source libraries that are out there, Pickle in this particular case, if you actually read this, it specifically calls out that it is possible to construct malicious packages which will execute arbitrary code on your machine. The warning's in there. If you look at NumPy, same thing. It actually leverages Pickle. It tells you that if untrusted data makes it into this very popular library, the ability to actually have remote code execution is liable to exist. JobLib, Pandas, the list goes on and on and on. These warnings are actually in there, but if you're not aware of them or aware of the security implications associated, it makes it very, very difficult in order to understand them. This one in the top left is a little teaser to what we're going to talk about with the ShadowRay, right? As far as the dashboard associated with Ray being exposed. Last year at Black Hat in 2023, our research team actually published a shadow vulnerability for SnakeYAML. This is a very popular open source library in Java. YAML's everywhere, and so parsing YAML files is very common. Anybody familiar with SnakeYAML? I don't know if I'm talking to developers here, or mostly security. All right, cool. So it's a very popular open source library that's used to actually parse YAML files. However, if you look at some of the details associated with this open source library, it specifically calls out that you can construct any Java object. Any Java object includes doing things like this. Using the ability to actually call out a remote jar file and tell it to execute it on your server. The telltale definition of remote code execution, right? It's built in there, it's the capability. When you look at the documentation associated with it, it specifically says it does not restrict you from being able to do this from any source or location. The maintainer, when we identified this, shared it back with them, said, this isn't a problem, right? It won't fix it because there is no problem. There are two options inside of SnakeYAML. There's a default constructor, and then there's this safe constructor. Guess which one is the default? I said default, but the default one is actually the one that exposes you to these attacks. And unless you read the documentation, you don't know that the safe constructor is actually the one you need to in order to ensure that that doesn't happen in your example. This is a perfect example of how it's not necessarily a bug, it's considered a feature, right? The flexibility associated with the library to perform these activities is built in there. However, if you're not aware of them and the security implications of it, if you utilize it in the wrong way, it exposes you to these types of attacks. So that's the idea of a shadow vulnerability. Here's the other interesting thing. There's no way to discover and identify these. You can't use software composition analysis, static analysis to discover these because there's no CVE to identify it in the first place. This is why they're considered shadow vulnerabilities. So that idea, that concept, right, with open source components. Now let's take that and apply it to AI. When we start looking at AI, you can take AI and put it into a couple of different buckets and categories. You've got the model, right, which is This is the large language model. This is the algorithms associated with the AI itself. And then you've got the components that it's actually built on and runs, the infrastructure associated with it. A lot of this is all open source. And there's vulnerabilities associated with the model. There's model poisoning, the ability to manipulate the algorithms. But more importantly, the AI engine itself that executes these functions is all built on open source. And there's tons of these. Anybody here familiar with some of these that are up here? Okay, cool. PyTorch, Airflow, TensorFlow, Spark. We'll talk about a couple of these where we have discovered multiple shadow vulnerabilities. Like I said, I'm going to focus in on one, which is Ray. But Jinja, TensorFlow, PyTorch, we've disclosed multiple of those as well. They're all in our blogs on our website. So why are shadow vulnerabilities common in AI? This is probably a rhetorical question, but the technology is being adopted very, very fast. The last talk was about a venture capitalist, and I think he said if your company that you're building has 2 letters in it, starts with A and ends with I, you're most likely to get attention and funding because the adoption and the need for AI is exponential right now. And so it's being adopted extremely fast. It's also a huge goldmine for attackers. If you look at AI, it has access to tons and tons of data and some very interesting resources as well. And we'll talk about some of those specific ones. The other interesting aspect of this is AI is being driven by data scientists, right? These are individuals that their number one task is to build these AI engines as fast as possible so they can be leveraged by the industry and not necessarily focused on the latter part of that. What are the security and the security controls associated with it? They don't necessarily have that expertise to actually know what that is as well. The last little piece too is AI is just code. The code that runs it, the models themselves are just code. Like all of this are just applications. It has a fancy term, artificial intelligence. The underpinning is just code. A lot of that's based upon open source and open source components inside the code itself and the models, as well as the infrastructure that it runs on. You're only strong as your weakest link in this particular case. These are why attackers are actually targeting it. And I'll show you some examples and we'll talk about what we discovered. But pricey GPUs. I'm sure everybody's familiar with the fact that NVIDIA has taken off, which was surprising to me because I always remembered NVIDIA as the graphics driver for Doom back in the 90s, right? But the fact that it's actually now the GPU resources that are being utilized for running these AI engines is very, very pricey and a very costly and phenomenal resource. It's a target for a lot of these attackers. There's a lot of sensitive data. These large language models have to have massive amounts of information inside of them. That is a huge goldmine for attackers. The applications themselves are user-facing. Organizations are using them, the data is being exchanged. It makes them a target and an easy area for attackers to actually get. And then the last one, we touched on this just briefly. The rate of adoption of AI is also the fact that it's new code. It's not had as many eyes on it and the ability to review it and identify these security risks. That adoption is actually, the speed of that adoption is actually detrimental in this case because it hasn't had the ability to be vetted from a security perspective. So take those things into account. And what we've already started to see is there are real-world shadow vulnerabilities in all of these engines. As I mentioned, we've disclosed these. We've gone through proper disclosure processes and made everybody aware. TorchServe, this one we actually called ShellTorch that we published. There's one in TensorFlow and Jinja. I'm going to spend the next few minutes talking about the one that we discovered in Ray. Who here is actually familiar with Ray or ran into it before? A couple, okay. Ray is the easiest way to describe it. Think of it as the Kubernetes for AI. Running workloads, creating processes, and it's used by who's who. I mean, you can tell anybody that's running has significant AI, anywhere from Uber to Netflix to LinkedIn. the biggest AI vendor out there, OpenAI, specifically calls out in their documentation, they use Ray to help train their engine. So it is used widely, right? Very, very popular. It has phenomenal capability as far as multiprocessing and parallelism of the ability to actually perform all of the tasks needed for AI. So that's the foundation of shadow vulnerabilities and start talking about open source and AI. Here's where we transition into what we discovered. And this is the ShadowRay and ShadowRay details. We did disclose this and share it also at Black Hat this year. So this was one of the things that we shared as part of that presentation and what our research team did. When we started looking at Ray, what we noticed was in November of 2023, there were 5 vulnerabilities that were published by any scale. When we looked at those vulnerabilities, 4 of them were fixed, but 1 was disputed. When you started looking at the details associated with the disputed vulnerability, it was determined that this isn't a bug, this isn't a vulnerability. Ray was specifically built to have this flexibility of being able to run and do jobs in an uncontrolled environment. Basically, the jobs dashboard, the jobs REST API, was exposed on the network that it was installed on to anybody to create jobs. And so if you look at this, the maintainer's position is, the intention was that it is for jobs to run remotely. If you wanted to have authentication, security controls, they should have been on top of that engine. If you look at out-of-the-box documentation in the installation, it installs and exposes everything to 0.0.0. How many of you want to guess that somebody might have installed this in an environment exposed to the internet? Sure they did. This is exactly what our research team said, was like, you've got individuals may not have security prowess that are installing this, that are data scientists working on these projects, trying to create them at a rapid pace. They might install them in an environment not knowing that it exposes itself and its jobs API to the entire internet. And so the first thing that we did, calling it somewhat reverse fuzzing, is to say, well, let's just go scour the internet and see if we can find some of these exposed. And this is what led to our discovery. We found literally thousands of these servers exposed. And when we started to get into the details, we actually realized that they had been exposed for close to a year. Which means anybody that stumbled on them beside us, because we're not the only ones that saw that disputed CVE, attackers are very much aware of any of these disputed CVEs all the time as well. So when we started getting into it, one of the more interesting pieces of this vulnerability, so it exposes 0.0.0, which means the jobs dashboard and the REST API is exposed and everyone on that network has access to it. One of the other interesting things that it does is any request or job that's actually run through that API is shared back in the console. It made the threat hunting of seeing what actually occurred very, very easy for us to actually see all of these attacks. So as we started to explore these, we were able to see exactly what happened. Access to a password, and these are the attacker's commands that are running on these remote servers. When we explored a few of the ones, again, through responsible disclosure and made everybody aware, these are some of the things that we were able to identify in these exposed environments. So we had AI production workloads, the IP that these AI engines are creating. We saw production database clusters, the access to the information that these AI engines had. Passwords. These are all obfuscated because these are from real sort of investigations when we were doing our threat hunting. SSH keys, which makes it very, very easy for attackers to traverse inside of your network and connect to other machines. And we started to see things like OpenAI tokens, the ability to actually access AI resources, as well as large language models with Hugging Face tokens. There were also This one was actually odd. Our research team said they couldn't quite understand why there were Stripe tokens on AI engines, but Stripe tokens for processing payments were made available and exposed in some of these engines as well. So the amount of information and data and access that was exposed from simply this default configuration of an AI workload engine is what resulted in what we were able to start to discover, that not only were all of those details made available to us, but when we started looking at the jobs dashboards, we quickly realized that the attackers were abusing this just as much as we were exploring it. And one of the first things we saw, that almost every attacker was setting up reverse shells on the servers as soon as they connected with it. What was also interesting, we saw multiple examples of attackers installing crypto miners on these GPU resources. In one example, we saw attackers battling each other to disable their crypto miner so that they could turn the other crypto miner on, and it went back and forth. The idea is when we started exploring this, we actually were able to quantify that it was billions of dollars of compute resource that was being utilized. They were competing with each other, turning the others off and then starting theirs. Yes. This is why, and I don't know if any of you saw this, this is why we had an exclusive with Forbes, because it was one of the first largest wild exploitation of an AI engine. And again, the fundamental capability is the fact that it's just another application. It does something different, but it's just another application. It's based upon the same sort of core components that all of us have been fighting and trying to address the risk associated with applications throughout our entire career. I started in security 25 years ago. SQL injection, cross-site scripting were the number one, number two at the time. It's not much different. They may have changed positions, but the same vulnerabilities still exist today. And they're more prevalent in open source now as opposed to first-party code. So that was the discovery, right? So this is what we discovered, we disclosed. The fact that the AI infrastructure has some of these weaknesses. It's very tricky to identify. There's no easy way to do that. So one of the things that we did when we presented this was to make sure that we promoted awareness. And as much as possible, start to help get behind the idea that this idea of shadow vulnerabilities needs to be shared more prolifically. Everybody needs to be aware that even though these CVEs may be disputed and the configurations are, this is how it was built, it's insecure by design, it needs to be shared much more easily. So this is something that's going to have to evolve. There's not an easy sort of fix associated with this. It does fall into the spectrum, though, of one of the things that we do at Oligo, which is the fact that sometimes a runtime solution is the only way to identify these, to look for the use or the configuration of these misconfigurations, know about the actual vulnerabilities that aren't necessarily published vulnerabilities, but the risk is there. One of the things that we've done is actually this idea of open source library sandboxing, which is looking at individual libraries and understanding the behavior of what they're supposed to do. If you look at Snake YAML, it's a YAML parsing library. It should read in YAML files and output data. It shouldn't be spawning code processes, communicating with a network, right? These are deviant behaviors outside of normal sandboxing capabilities. And it's one of the approaches to actually looking for this type of data. The other one is to say, well, are you using the unsafe constructor in Snake YAML as opposed to this safe one? And the ability to proactively identify those as well. What that allows the ability to do is to actually detect when there are no CVEs. So in these cases that we've been talking about, they've been disputed CVEs, but what if it's something that nobody's discovered and disclosed yet? What if it's a new type of attack that's not been available? How do you get ahead of it and actually understand that? And it's one of the areas that we focus on. This is actually an example of just that. This is another AI infrastructure component called Keras. This is one where we saw a deviation in the library where it started to perform activities that were outside of its normal behavior. There's a call stack here associated with what we saw and what we alerted on, and when this tried to spawn a child process, we were able to identify that and alert to say this is deviant behavior, goes outside the norm of this normal open source library, and therefore is a telltale sign of an indicator of compromise. So I know I did that really fast, like 30 minutes. The idea is I wanted to convey the idea of shadow vulnerabilities, what they are, what we're seeing in the market, be able to promote awareness associated with those, why they're here and why they're here to stay, because open source usage is pretty proliferate. The fact that they exist inside of AI. AI is built on top of open source components, and some examples of real world shadow vulnerabilities. As I mentioned, we talked about Ray today, but we've got examples of this with TensorFlow, with PyTorch, and several others where the configuration associated with those exposes. And then the last one was just a need for a way to actually identify and look for these risks in order to make sure that you're covered. So with that, unless I talked really, really fast, I went through that very fast, but I see at least one question.
Yeah, first of all, thanks. It was a great talk, very informative, very scary. So well done.
Yeah, it was our research. I loved presenting this, and I'm not taking credit for it, but our research team discovered this, but it was very impressive when they started sharing it with us once they found it.
So this may be an obvious question, but can you elaborate a little more on how you get from the ability to remotely execute jobs to discovering all these API keys, SSH keys, things like that? Like how did you extract, where was that being extracted from?
Yeah.
How were those things that the models were able to have access to?
Yeah. So what's interesting is when our research team discovered sort of this exposure of all of that Ray engines, we used and started to leverage the exact same attack techniques that the attackers were doing. Establishing reverse shells, executing that command that was displayed here of simply querying or executing a command to show the password database on a machine and server. So we leveraged the exact same approaches that attackers were doing in order to expose what all of the Ray infrastructure had access to. Not necessarily unique, it's just standard approaches for actually abusing these infrastructures.
So you mentioned that one of the issues with AI technology is that it's built on code that hasn't been vetted, but people are implementing it super quickly with this idea that, oh, it's shiny, it works, look, it can generate all reports for me, it can write my code, people using it without any skepticism or error checking and stuff. So how do you, it's obvious to security professionals that you shouldn't be pasting all of your emails into an AI bot, right? But how do you socialize that to people who say, oh, well, that's just, you're being too kooky, you're worried about too much. Like, how do you socialize that concept across a business if there's people that don't see an issue?
Yeah. So now you're getting, which is very interesting because it's one of the talks I actually sent in on earlier today, which is how do you actually communicate to the business the risks in business terms? Because you're spot on, right? There's the creation and utilization of AI internally, which was what was exposed here. But then there's just the use and consumption associated with that in generic form. And people are not thinking twice about doing exactly what you said. It's like, I'm going to send them all of my emails and tell it to summarize and get back. And it's like, well, wait a minute. Would you forward your entire email database to someone randomly? Because that's exactly what you're doing. In addition to the fact that if you don't understand sort of the licensing agreements with those, you don't know how those are being utilized or where that information is getting shared. So that's an education. Like it's a difficult hurdle of but I think the process is putting it into some very simple terms that can be related to, I understand you're using this, but here's the equivalent, right? Is you're taking all of those and simply forwarding your emails and then saying, hey, go post-process this for me, right? Whether that's some random individual on the street, or in this case, happen to be doing by an automated algorithm that's performing that for you, which could in turn store that use it for other purposes, expose the information inappropriately, because if you don't know the agreements, you don't know how it's exposed. Probably not the best answer, but yeah.
Yeah, I'm curious. You talk about the documentation. Could anywhere erase documentation describe the 0000 should be replaced by actually, for example, internal IP address or something like that?
In the default documentation, it doesn't actually call this out. This is what happens. But if you do, I believe it is actually shared somewhere in there. And the fact that the maintainer's position in this particular case was it's intended, right? It's meant to be exposed on the network that it's installed on. But it didn't specifically call out don't install it in areas without proper authentication and controls and provisioning associated with those resources. So I think this is the challenge with some of these open source maintainers, because it's like, well, I'm building this for you for free. Now you're asking me to put all of these additional controls on top of it to build like this enterprise solution. It's like, I'm giving you the component. Use it appropriately. And the issue is between these two worlds, you have sort of consumption of this that may not be aware of all of the security implications associated with default installations that exposes you to these types of things. And knowing about them and checking them becomes extremely critical. Staying on top of it and trying to stay aware of any of these risks that are being installed in your environment is difficult. Go ahead.
I have so many concepts going through my head. So like I started out with documentation and getting to exposing the ports and all, but you'd think that this open source, you'd be able to go back to them and say, hey, this is unsecure by design. There is no zero trust here. And you need to label that on your site as somehow to anybody who's using it and goes to your site to download your code, it's right there readily available. So my question is were you guys able to go back to that developer team and address it with them?
We did. So as part of going through this, we had responsible disclosure processes where we obviously reached out to Anyscale and discussed this with them. But again, it was an already disputed CVE. So it's not like they weren't already aware of it. Exactly, disputed. And this is what happens with many different, as a matter of fact, it's an area that we're focused on is looking at disputed CVEs, because a lot of those probably create risks that a lot of people don't know exist because it's working as advertised. We put the warnings in there. It's meant to be sort of very flexible associated with the model. If you don't use it appropriately, the burden is on you.
But it's not real evident.
It's very tricky unless you look at, you're correct. And that's the part that's, yes, looking for some way to expose those in a much more effective way so that everybody understands this risk. Because everybody is struggling with the risk of the fact that just the regular CVEs are constantly being discovered and disclosed, and staying on top of those and making sure your exposure is. But what about the ones you don't know? And it's, in this case, we're talking about disputed CVEs, but then there's also sort of unknown unknowns too, which is a whole nother world.
In this case, I think you can swap the word risk out with danger.
Yes, because this one exposes you, because the interesting part about disputed CVEs is the disputation, I don't know if that's a word. It is now. It is now. Is made publicly available to everybody. Right. That's exactly what our research. It's not any different than what our research team did. Was like, wait a minute. If this is the default installation, is there any way anybody installed this in the wrong environment? And we found, and we weren't able to publish and share every single organization that we discovered and shared it with, but there were some significant organizations that had this installed with data models. And those passwords and database access were from large organizations that we'd stumbled upon, not just these little mom and pops that were experimenting, but massive universities, massive retail companies. Like, they were significant sort of exposure of data that could be taken advantage of.
Yeah, I was going to ask
So what techniques did you guys use to like profile and like sandbox those like open source?
So that's one that is based upon sort of our technology. Is we've basically discovered a way to look at an app very unintrusively from an outside perspective and be able to identify the libraries or functions and what kernel level activities they perform. Because of that granularity, we can identify and create these sandbox profiles associated with in sterile environments. We know why the libraries are built, which then allows us to for these deviations. What's cool about that, we can do it without modifying the applications or code. So we can do it for code you build, code you buy, it doesn't matter. But the ability to perform that activity allows for sort of those anomaly detection of the behaviors.
Did you have a metric about how many of these installations were done in cloud environments, like public cloud environments versus private cloud environments?
That's a good question. I don't know if there is. I don't have that metric. If we did, I know some of them were in public because we saw the AWS keys and credentials and a lot of that data. I'm not sure how many of them were in their own data centers that were exposed. Not off the top of my head. Yeah. Any other? That actually took me up to my time almost. It's intriguing. It's just because this is how everything evolves, and the attackers are always trying to stay, 2 steps ahead, take advantages of whatever advantages that they can get in order to actually utilize these resources. Cool. If anybody figures out how to monetize hurricane activity, let me know. And if
fraud.
Cheers. I'm not going to suggest I haven't explored that.
Cleanup and preparation service.
That's true. Yes. Yeah. But a shovel and a wheelbarrow can only make you so much money. Write a book. That's what I could do. Perfect. Stilts are very, very important. Yes. But I appreciate the time. If both Nikhil and I are with Oligo, so if you guys are ever interested, like I said, hit our blog, look at these other ones, because there's a few other shadow vulnerabilities we have up there. We share all the details associated with what they are. Cool. Thank you very much.